Welcome to Math TV with Professor V. This is video lecture for college algebra on section 1.3 complex numbers. So just a recap of some definitions. A complex number is a number of the form a plus bi, where a and b are both real numbers. A is called the real part of the complex number. B is called the imaginary part of the complex number, and I is the imaginary unit. By definition, I is equal to the square root of -1, and therefore I squared is equal to -1. Now, if this is your first time dealing or delving into complex numbers, I recommend, I'm going to link a video here where I give a little bit more of a basic introduction as to why we need them and how they enable us to solve more equations, just to give a little motivation behind the topic. And I don't love that we use the word imaginary to describe this unit here, because a lot of times people associate the word imaginary with make-believe and things that are pretend, but I is very much real in the sense that it has applications and it's necessary in the real world to, do computations and solve things, and it's essential in calculus as well. So just think of that as opening up the field of numbers, field of solutions. It's not fake by any means, okay? Anyways, let's just practice now adding or subtracting complex numbers, and then we're going to get into a little bit more advanced techniques. And you do this the same way you would add and subtract like terms with any sort of variable. So you can just treat I, the imaginary unit, like you would a variable. Example 1 says, write each expression in the standard form a plus bi, and it is important that you put the real part first and the imaginary part second, okay, when asked to write them in standard form. So here, for example A, we're just adding together these two complex numbers, 2 minus 3i plus -4 plus 5i. So I'm going to collect my like terms, 2 minus 4, that's -2. And then I have -3i plus 5i, that's going to give me positive 2i. And that's it, we're done. See, that was pretty painless. Okay, example B, now we have subtraction here. So let me distribute that negative. We have 2 plus 3i plus 4 minus 5i, right? And then again, collecting like terms. So the real part's 2 plus 4, that's 6. And then 3i minus 5i, that's -2i. Box it and move on with your life. Fabulous. Now we're going to move on to multiplying complex numbers. We're going to need to use the distributive property, foiling, all that jazz. And then keep in mind that I squared is equal to -1. So as you're working, if you see I squared pop up, replace it with -1, okay? Write each expression in the standard form again, a plus bi. So here we go. So we've got 2 times -4, that's -8. 2 times 5i plus 10i. -3i times -4, that's plus 12i. And then -3i times 5i, that's -15i squared. Voila. All right, so let's go through, simplify further. So we've got -8. These two terms here are like terms. So I have plus 22i. And then as the little reminder stated, I squared is equal to -1. So I'm going to replace that I squared with -1. So now I have -15 times -1. Well, that really just gives me a positive 15, yes? So positive 15 and -8, that's going to be positive 7 plus 22i. Okay, again, the real part has to be first. So normally, yes, it's true, addition is commutative, but it would not be correct to write 22i plus 7 because that's not in standard form. Imaginary part comes second. All right, now we have 2/3 plus 1/2 I quantity squared. You can write that quantity out twice in FOIL, but that's the equivalent of like counting on your fingers. So let's remember the formula when we're squaring a binomial. A plus b squared is a squared plus 2ab plus b squared. Beautiful. So A in this case is 2/3 and B is 1/2 I. Can you see it? All right, so A squared, when you square a fraction, you square the top, square the bottom. So that would be 4/9 plus 2AB. So 2 times 2/3 times 1/2 I, that's 2AB, plus B squared. 1/2 I squared is going to be 1/4 I squared. Now, I'm going to be honest, I don't normally write out this much. I can just do it in like 1 or 2 little steps, but I wanted to break down the formula to convince you to use it because it will save you much time. Okay, so we've got 4/9 plus, look at this in the middle right here. These 2's cancel. Don't we love it? So we've got 2/3. That I is not in the denominator. No. So this is 2/3 I. And then remember, I squared is -1. So I'm going to do something kind of slick. Are you ready? Are you ready? I'm going to just change this sign to subtraction because I know I squared is going to change the sign of that last term. So I have -1/4. I know. Okay, last thing I need to do is just collect like terms. So 4/9 and -1/4, those are both real numbers. So I need to perform that subtraction. So 4/9 minus 1/4. It's common denominator time, yes? Times 4 times 9. So what do we have here? This is going to be 16/36 minus 9/36. So that's 7/36. And now we can finish off this problem. 7/36 plus 2/3 I. All right, very good. How did you like that one? Yeah, I liked it quite a bit as well. Okay, dividing complex numbers. This is done by multiplying the numerator and denominator by the conjugate of the denominator. So remember, the conjugate of A plus BI is A minus BI and vice versa. This should remind you of when we rationalized denominators also, when we had more than one term in the denominator, like if you had 5 minus rad 2. To rationalize, we had to multiply by 5 plus rad 2. It's the same idea. So just like you don't want any radicals in the denominator for something to be completely simplified, you don't want any i's in the denominator. It's not considered simplified if you've got i's hanging out, okay? You want to get rid of them. And the way to do that when you're dealing with complex numbers is multiplying by the conjugate. It's called complex conjugation. Okay, so let's look at an example or two. Write each expression in the standard form A plus BI. So I'm looking at A, we've got i's in the denominator, not good. So I'm gonna multiply everything, top and bottom, by 3 plus I, okay? Good. So let's FOIL out everything in the numerator. 2 times 3, that's gonna be 6. Then we have plus 2i, plus 15i, plus 5i squared. And then in the denominator, notice we're just going to have a difference of squares. So we're going to have 9 minus I squared. Where did I get that? Well, remember, 3 minus I times 3 plus I. That's A minus B times A plus B. And we end up with A squared minus B squared. So I don't need to sit there and FOIL the whole thing. I know those middle terms are going to cancel out. That's the whole point of the conjugate. Okay. What's going on up here? So we've got 6 plus 17i plus 5i squared. Oh, I'm going to change that to minus 5. Yes, I'm so slick. And then we've got 9 minus I squared is -1. Okay, so let's see what we've got going on in the numerator. 6 minus 5, that's 1 plus 17i over 9 minus -1 is 9 plus 1 over 10. Do not write your answer like this. Split that denominator because we need to see the real part and the imaginary part. Okay, so typically homework is a little more particular with these complex numbers that it has to be A plus BI, and you don't put them in over the same denominator. because you want to be able to easily identify, oh, this is A. Oh, this is B. You see what I'm saying? Okay, let's work on another one. You want to give it a go? Why not? Pause the video. Try it on your own. I hope you tried it. This is a safe space. Don't be scared. Okay, 3 minus 2i. Yeah, is that what you chose? Wonderful. So FOIL out the numerator. Let's see. We've got negative 6 minus 4i. No, I'm lying. Plus 4i. Forgive me. Plus 12i. I don't like that I. It needs more of a tail. Yes. Minus 8i squared. And then in the denominator, again, we're going to end up with a difference of squares. So this is going to be 9 minus 4i squared. Perfect. Okay, so now let's see here. We've got negative 6 plus 16i plus 8 over 9 minus 4i squared. That's going to become 9 plus 4. Very nice. And then collecting like terms in the numerator, negative 6 plus 8, that's 2 plus 16i over 13. And then we don't leave it like that, right? No, no, no. We're going to split up the real and imaginary part. So 2 over 13 plus 16 over 13i. And that's it. Okay, very nice. Now, we're going to look at simplifying powers of I. I actually have a whole separate video on this, but I'll just do a little recap so you don't have to keep hopping around. By definition, we said that the imaginary unit I is equal to the square root of negative 1. I squared is equal to negative 1. And then here in your notes, it says, therefore, I cubed equals negative 1 and I to the fourth equals 1. That may not be obvious to you, so I want to break it down. And I'm actually going to show you a way to do the next set of examples differently than the textbook, okay? So I cubed is negative I and I to the fourth is 1. Where's that coming from? So the imaginary unit I, by definition, is the square root of negative 1. And hey, when we see it, we leave it, right? Okay. When we see I squared, we replace it with negative 1. I cubed is equal to I squared times I. Yes? That would give me 3 of them. Well, since I squared is negative 1, this is negative 1 times I, which is where negative I comes from. And then I to the fourth, that's I squared times I squared. So that's negative 1 times negative 1, which is positive 1. And then the cycle repeats. So I to the fifth, you could write it as I to the fourth times I to the fourth, we just saw, I to the fourth is 1. So that's 1. So that's 1 times I, which is I. I to the sixth, you could write it as I to the fourth times I squared. I to the fourth is 1. I squared is negative 1, so this is negative 1. So you see how it repeats? I, negative 1, negative I, positive 1. I, negative 1, every 4. I to the seventh, I'm not even going to do it. You should know, negative I, and then I to the eighth, positive 1. So as long as you remember the cycle repeats every 4, you're in business. Cycle length 4, and know what the first 4 powers are. So how is this going to help us simplify? Well, let me show you, okay? So we have to simplify I to the 352 plus I to the negative 125. Okay, so I to the 352, you don't want to sit there and have to go up to 352. I just want to know, does 352 land on the first one, the second one, the third one, the fourth one? Like, where does it land in the cycle, right? So since it repeats every 4, I'm going to divide 4 into the exponent. You always divide 4 into the exponent. And I'm interested in the remainder, because the remainder is going to tell me which power of I it will correspond with. So let's see, 4 into 35, let's see, that's 8 times, right? 32. And then subtracting, this is 3, bring down the 2, this is 8. So we've got no remainder. Okay, well, of these 4 powers of I, 1, 2, 3, 4, which one would have no remainder if I divided by 4? The only one that divides by 4 evenly is I to the 4th. So what does that tell me? Since the remainder is 0, I to the 352 is equal to I to the 4th, which is positive 1. So I have that part taken care of, okay? I know, wasn't so bad. Okay, what about 125? I know it's negative, I'll deal with that later. How about that? Let's not stress ourselves out too much. So let's again divide 4 into 125. Always divide by 4. Why? Because that's how long it takes for the pattern to repeat, the powers of I. Okay, so 4 goes into 12 3 times. 12. Bring down the 5. 4 goes into 5 once. And all I'm interested in is the remainder. So what does that tell me? That tells me I to the 125 is equal to I to the 1st, because that's the remainder. Okay, if you have I to the 1st, you just leave it, right? We've been writing out complex numbers, 2 plus 3i, blah, blah. You don't have to replace it with anything. The only thing is, this is I to the negative 125. So I to the negative 125, that's 1 over I to the 125, which is 1 over I to the 1st. And normally, we'd be happy about things, but we're not, because remember, you can't have I in the denominator, just like you can't have radicals in the denominator. Think of it much the same way. Now, earlier we talked about multiplying by the conjugate to get rid of I from the denominator, but this time notice there's just sad little I all by himself down there. And you're going to fix this much like you, again, think of rationalizing denominators. If you had 1 over rad 5, you just multiplied by what you were trying to get rid of. That was the more simple case. Same thing here. I, you must go away. Okay, I'll multiply by I like that. Oh, okay. So then now we have I over I squared. But what's I squared? Negative 1. So we've got I over negative 1. Who cares what page this is? Go away. We need some space. And then that's going to be negative I. All right. So at long last, we have positive 1 and negative I. And I can just write out, I wouldn't put 1 minus I. Oh yeah, I would. Positive 1 minus I. There it is, standard form. I know, it took quite a bit of work. And it looked like it was going to be a harmless little problem. Right? Oh, it did not look threatening to begin with. And look how much we had to think. It's okay. The next few will go more easily, I promise you, now that we've had that discussion. So let's give a few a try, okay? Well, actually, just one more. That's enough. Okay. 2i to the 140 or to the 47th power times 2 minus 3i to the 75th. If you were to ask me, I would distribute first, because I don't want to simplify the powers of I, distribute, and then need to simplify again. I'm not in it for multiple rounds of this business. Okay, so this is going to be 4i to the 47th minus 6i to the, we need 47 plus 75. I did it earlier. I got 122. Let's check if it's the same thing on a Saturday morning. It is. Okay, 6i to the 122. Okay, so again, we need to simplify I to the 47th power and then I to the 122nd. Divide both of them by 4. All right, so here we go. So 4 into 47. 4 goes into 4 once. 0. Bring down the 7. It goes to 7 once as well. I don't care what the quotient is. I'm all about this remainder. Remainder 3. So that means I to the 47th is equal to I to the 3rd. And what's I to the 3rd? You do have to memorize this. Negative I. Okay, so we've got that part done. Now I to the 122nd. So 4 into 122, that goes 3 times, 12. 0, bring down the 2. It does not go into 2. So that's the remainder, remainder 2. What does that tell me? That I to the 122nd is the same as I squared, which is negative 1. All right, so now I'm going to substitute in the simplified powers of I into that expression right there. Okay, so come down here, and we're going to have 4. Instead of I to the 47th, I'm going to put negative I minus 6 times. Instead of I to the 122nd power, I'm going to put negative 1. So this is negative 4I plus 6. We don't leave it like that. No, no, no. Real part first. So this is 6 minus 4I. Okay. And I do have to give credit, this method of dividing by 4s. It was not in any of my textbooks. I did not think of it. I came home in tears, confused, angry at math, and my mother explained this to me, and I've loved it ever since. So credit to Professor A. If you haven't seen her, I'll link this video here where she talks about herself. Okay, now that we're so professional with complex numbers, let's solve equations using them, okay? Example A, x squared plus 25 equals 0. So for these quadratic equations, solve them how you like. If you can factor, factor. If you want to use the square root property, go for it. Otherwise, we do have to use the quadratic formula. This first one is pretty easy because I just have x squared and a constant. So I'm going to use the square root property. So x squared equals negative 25. And then I'm going to go ahead and take the square root of both sides. Don't forget to put plus or minus on the right side. And then now I have x squared equals plus or minus. If you just need a little review how to simplify square root of negative 25, remember it's square root of negative 1 times 25. Oh, there's no more squared here, forgive me. So this is going to be plus or minus square root of negative 1 square root of 25, which is going to be plus or minus I, square root of negative 1 is I, yes? Good, times 5. And that looks peculiar. We don't write it that way. We put plus or minus 5I. So basically, if you're taking the square root of a negative number, the result is whatever the square root would be if the number wasn't negative, and then you just slap an I on there. That's really all there is to it, yes? So you don't have to go through all these steps every single time. In fact, no one really wants to see it. So you could just say plus or minus 5I. Okay, good. Example B, 13x squared plus 1 equals 6x. So this one, I can't use that square root property that I did for the previous example. Why? Because this 6x right here is ruining everything for us. So let's set this equation equal to 0. And I'm not feeling hopeful about it factoring, so I'm thinking it's quadratic formula time, you know? All right, let's list out. A is 13. B is negative 6, and C is 1. So x equals opposite of b plus or minus square root. B squared is going to be positive 36 minus 4 times 13 times 1 all over 2a. So 2 times 13. So let's see, this is going to be 6 plus or minus the square root of 36 minus 52 over 26, which gives me 6 plus or minus square root. 36 minus 52 is negative 16 over 26. Okay, so square root of negative 16, remember what I told you. You take the square root as if you normally would if the number wasn't negative, so that would be 4. And then just slap an I on there. Yes, so 6 plus or minus 4I over 26. And I'm not going to leave it like that. We're going to write it as 6 over 26 plus or minus 4 over 26I. Is that ready to be boxed? No, it is not. We have to reduce those fractions. So this will be 3 over 13 plus or minus 2 over 13I. And now we're done. Whew. Okay. How satisfying though. Normally you would say, like, when you're a beginning algebra student, this has no real solution and you would just be done, right? Because the discriminant's negative. But now we can continue and find solutions to more equations. Okay, example C, x cubed plus 27 equals 0. For this one, you need to be very careful because there's actually 3 solutions in total. Later, when you learn your fundamental theorem of algebra and the nature of solutions, you'll see that whatever the degree is on your polynomial equation, that's how many solutions you should have. So basically what I'm getting at is if it's x cubed, you should have 3 answers. And if you were just being careless and you said, oh, x cubed is negative 27, cube both sides, you would get x is negative 3. But where are the other 2 answers? Oh my goodness, they're hidden. So to extract them, we actually need to factor x cubed plus 27. So it's a sum of cubes. Factor it using the pattern for factoring a sum of cubes. I'll link a video here if you forgot how to do that. So it's going to factor into, I always think SOAP to help me fill in the signs, you know, x plus 3 times x squared minus 3x plus 9. This equals 0. Okay, this trinomial here does not factor, right? And so now I'm going to use the zero product property and set each factor equal to 0. So x plus 3 is 0, or x squared minus 3x plus 9 is 0. I can see right away x plus 3 equals 0 means x equals negative 3. That was that first answer that we just found, right? But the other 2 answers are sitting in this quadratic equation. I just said it didn't factor, so what else do we do? Sit and cry? No, we use the quadratic formula. Okay, so we've got here, let's do it right here. X equals opposite of b plus or minus square root. B squared is 9 minus 4 times 1 times 9. All over 2a. Okay, so this is going to be 3 plus or minus square root 9 minus 36 over 2. So this is 3 plus or minus 9 minus 36, that's negative 27 over 2. Okay, so how would you normally simplify square root of 27? It's 9 times 3, right? So you would put 3 rad 3, but because this is negative, then you're going to have 3 plus or minus 3i rad 3 over 2. Ooh. Okay, I've been like a stickler on writing them in standard form. So it's 3 halves plus or minus 3 rad 3 over 2i. Okay. If your instructor lets you stop here, then that's fine. I'm not mad about it. I'm just prepping you in case you have a stickler instructor, as I am. Okay, so this is 2 answers, right? Plus or minus, 1 for the plus, 1 for the minus. Here's the third answer. Don't leave it like this, making your instructor go on a scavenger hunt. You put them in a lovely solution set. So we could have negative 3, comma, you don't have to list the other 2 separate. You could put plus or minus. And the order does not matter. There's our final answer. Wow, wow, wow. So beautiful. Cute. Okay. Last one's actually easier. Yes. You'll leave this lecture feeling fabulous about yourself. X to the 4th plus 3x squared minus 4. This one actually factors. Believe it or not. I know. So pretend it was a squared plus 3a minus 4. Could you factor that? Yeah, it factors into a plus 4 times a minus 1, right? And coming up very soon, we're going to study equations that are quadratic in nature, even though they're not. Like this equation, it's not quadratic. Quadratic means the highest power is x squared. It's got x to the 4th, but it still follows a similar pattern. So I can factor it very similar. Look at this little template here, basically. It's going to factor into x squared plus 4 times x squared minus 1 is 0. Do you see that? Oh, good. Okay, so then now we have x squared plus 4 is 0 by the zero product property, and then x squared minus 1 is 0. And each of these you can solve, they're so cute, using the square root property. So just move the constant to the other side, and then take the square root of both sides. Just don't forget your plus or minus. So we've got x equals plus or minus 2i, yes, very good. Or x squared equals 1, square root of both sides, put that plus or minus, love it, x equals plus or minus 1. And then those are all 4 of our answers. I'm not surprised that there's 4 answers. This equation was degree 4, x to the 4th. I expected there to be 4 lovely little solutions. So that concludes the video. In the next video, we're going to do more equations that are reducible to quadratic, that basically have a form of a quadratic equation, even though they're different. And we're going to solve some radical equations. So you're just going to be an equation solving machine very shortly. Give the video a thumbs up if you haven't already. Don't forget to subscribe. Feel free to join if you would like access to exclusive content, early uploads, all that jazz. Talk to you guys soon. Bye.